Exactly.
So I mentioned epigenetic aging clocks. Are you doing epigenetic aging clocks in dogs? And if so, what are some of the initial results?
I feel like we have to if
Yeah.
we're studying aging, right? I think there's
I knew the answer to that question,
right.
but I'm just trying to lead
Totally.
you a
No,
little bit.
there's precedent for it, right? And there've been some clocks that have been developed in dogs in different ways, but none in a cohort as diverse and large as this,
Right.
right? And so that was the first thing that we wanted to do is, all right, how well can we predict the chronological age of these dogs based on their epigenome? Training it in, it's a machine learning based model, but basically we're just using statistical combinations of these different methylation states to say, how old is this dog, right? And so you probably have talked about this before in other podcasts, and your listeners probably know this already. But if you're a 10-year-old dog, then on average, your DNA methylation profile should look like a 10-year-old dog, should predict you to be 10 years old. But sometimes it's going to predict you to be an 11-year-old dog or a 12-year-old dog, right? Which we can think of, as maybe a measure of biological age in some way, right? And
an estimate of biological age.
Estimate of biological age, and though it varies a lot about when you measure it, and how you measure and all sorts of things. So we're internally consistent here.
Have all of the clocks that you've worked on in the dog aging project so far correlated to chronological age? Have you?
This podcast is produced by the Dog Aging Institute, a nonprofit supporting research to help dogs live longer, healthier lives. To learn more or support this work, visit dogaginginstitute.org.